Okay, so this is a follow-up to the Exoplanet video that I posted recently. And what I thought I would do here is to show how to conduct a more thorough analysis of the light curve data. This is thanks to a link that was shared with me by another Tycho user. So to go ahead and get started here, I'm going to switch over from the APAS catalog to the Atlas catalog. They both really, in this case, they work just fine, but my preference leans more towards Atlas just because not only does it have a lot more stars to work with, but also better sky coverage. So the mag band will stay the same. It's still going to be the V magnitude band. I'm going to click OK. And as you can see, there are certainly a lot more photometry stars available in the field of view. Same as before, I'm going to go to Photometry, find comp stars, and using this tool we can quickly identify good candidate comp stars using the search parameters here. And again, as before, the very first one here, I happen to know that is our host star. These are the coordinates of that host star. And so I'm going to not use that as a comp star. So just go with the next one here, add to the comp star list. And I like to go ahead and populate with about 5 comp stars here. And once I've done that, then I'll go ahead and, same as before, go to graph, generate data. And this can take a little bit of time just depending on how many images are in the series. In this case, there are 336 images, and it's going to create these measurements for each of the 5 comp stars. So we'll just go ahead and give it a moment here to do that. But once it is finished, then we'll be able to look at each comp star in detail. So here are each of the comp stars. You can click on each one, and these all look pretty good. None of them are variable stars. So that being the case, I'm going to go ahead now and navigate to the host star, which is right here. I could always go to location, specify coordinates if I wanted to do that. But anyway, this is the host star, and what I'm going to do is double check that I have the aperture I want to use. So this is something I already set up earlier. So the radius 1, so it's a circle, so it just has this option here. So we can adjust that if we want to. I'm just going to choose something that I think encloses it appropriately. So that looks pretty good to me. And a dead zone 4.5, and sky annulus of 9 pixels. And then I copy that the target parameters to comp star parameters. So both the comp stars as well as the target will be using the same aperture settings. So close that, and then I'm going to define 2 markers. Again, this is just because this could be a moving object, and so you'd have markers to define the start and stop motion of it. In this case, it's a stationary object, so both marker 1 and 2 are associated with the same position. So once you've done that, you can then click Generate Photometry Set, and so it's going to generate the data points here. So we give it a moment and graph the data. So here we are. This is a nice light curve to work with. And if you don't see this presentation exactly the same way, you can always go to Graph and adjust the scaling and so forth, floating or fixed range. But once you've populated that the way you want it, then you can save the data points to a repository. So by default, it will automatically save your work for the next session in case you forget to save it. You can go to Load from Autosave, but it's always good to go ahead and manually save it as well. So in this case, what I'm going to do is export to a tab delimited file. So this will allow me to load that into this other tool. Now it popped up an error message there. That's just because I didn't select the photometry set. There could be multiple photometry sets in this list. Here we just have one. So select it, export it, give it a name, export using Atlas. And so now we have the data file, and again, this is a web page that was linked to me by another Tycho user. This is a variable star and exoplanet section of the Czech Astronomical Society. So if you go to this web page here, then you can click on model fit your data. And so this is pretty cool. You can choose the exoplanet that you are working on. In this case, this is WASP-12b. So if I go ahead and find that here in the pull down menu, and then I specify the data file. So that's the one that I just created, and so they say it can be either space or tab delimited. So that's why I chose a tab delimited export. And I'm going to use the default settings here, then click continue. And same on this page, I am also going to use the default parameters, and then finally click on compute. So this is pretty cool because it is able to automatically detrend and so forth, and also compute the heliocentric Julian date midpoint, the duration, the depth, and so forth. So all these parameters here, it is able to take that light curve data that you saw here with Tycho, and then output this result. And so I think that's pretty cool. And if we wanted to do so, we could also compare these results with those that were published in this guide here. This is a practical guide to exoplanet observing, and so these images were taken for the purpose of putting together a guide on exoplanet analysis. So this is written by Dennis Conti. This is pretty well written, but anyway, he has his results basically at the very final page here in the guide. So this is the predicted midpoint, and then the model fit midpoint here. So he wound up with 393.60123. So if we wanted to, we could compare that with the value obtained here. So get out a calculator, 60123 minus 0.6025, and this is in days, fractions of a day, so this many seconds per day. And as you can see, the difference between our results and his, just 84 seconds with the midpoint. So that's a very good agreement from these two findings here. So again, Tycho, very quick to produce this light curve, and then you can take that and export to a tab delimited file, and then you can load it into this web page and generate a nice result here. So a future version of Tycho, maybe this will be integrated to some degree with some of these features, but for now, this is a pretty quick way to do it. So anyway, I thought that was pretty cool. So thanks for watching, and see you next time.